Right, hello. Let's hope this works. Here's a video. We're going to be building up today a full wave bridge rectifier circuit. I would like you guys to build the simulation and do the tests. Now, I'm on a demonstration version of the software, so I can't run the tests. So where I ask you to take some readings, you're going to have to do that and take the readings yourself. Okay, and then we'll look at those readings in comparison to theory on various websites that we'll look at as we're going through, and when I'm back we can confirm everything's right. Okay, so what we've got here, okay, is my drawing grid, blank screen. Okay, we're going to start. I'm going to put in a power supply, so we go to gallery, power supplies, and you want an AC power supply. This time AC voltage source, which is down here. Click that, drop it on, and then we double click that because we're going to make it a main source, so we're going to make it 230 volts RMS. That's important to remember. And 50 Hertz frequency, because that's what UK mains runs at. We'll not talk about 240, but it's 230. Okay, now we can't work with 230 volts AC, so what we need to do is put in a transformer, and the transformers are in inductors. Click it, and your transformer there, and a 10-to-1 transformer is absolutely fine. So we'll just drag that in and drop her about there. Okay, put the wires in, just click on the node. When it starts glowing, you can let go, and that makes the connection. So there's our input and output. Now this is the first point where we're going to do a test. Okay, so what you want to do, go to test instruments, click it, and you want your oscilloscope. Okay, click it and drag it up there. And we're going to use this oscilloscope quite a lot, but initially what I want you to do is drop channel 1 to read directly across your input, and channel 2 to read directly across your output. Okay, and then you're going to right click, go to add graph, and underneath, as big as we possibly can fit on the screen, set ourselves a graph. Okay, now at this point I want you to run your simulation. Now if you look at what it says when I try, I get this error message because I'm on the demonstration version. Yours should work. What you should see is just some lines. Okay, so what you need to do is right click in the graph, and you'll have the option to graph fit to data. Click that button, okay, and your graph should now show the sine wave. It might still be messy, at which point down here on yours you will see a time. You need to make sure the time is around 10 to 20 milliseconds, and that should then show you a nice set of traces for the graph. What you need to do is take a copy of that, screen grab it. Now what I would do is I'd go and I'd get my snipping tool. Okay, and the snipping tool comes up. Now unfortunately it's on the wrong, so the snipping tool appears, new snip, and just take a snip of that first graph, and then you can paste that directly into a Word file. Okay, so I'm going to just get rid of that for now. Okay, so that is still AC though. So what we now need is our full wave bridge rectifier. So I'm going to take the second trace out, okay, and the first trace out. So we're going to keep the oscilloscope up there because we're going to use it in a minute. Okay, now you want to go back to diodes, click the diodes button. You can see a bridge rectifier there. Select the bridge rectifier and drag it in to the circuit. Just drop it down there. Now what's important to know with this is the top and the bottom pins are our AC input. So that wants to connect to the secondary coil of our transformer. The other two pins are our DC, and that's our positive DC, that's our negative DC. Okay, so what we're now going to do is set, in fact before we do this, it's always best to set just a small load resistor for your current to go through, so we get a better trace. So go to resistors, set yourself a 1 kilo ohm resistor, that'll be fine. Pop it out, bit of distance so we've got room to put other things in, and connect it into the right part of the circuit, sorry guys, which is there, the positive DC. Now don't worry about that because I'm just going to move my resistor and tidy it all up, and then back to there. Now what your system might ask you for as well, so it's always safest to put it in, is come back to your gallery, select a power supply and give yourself a ground. Okay, sometimes it cares, sometimes it doesn't care, but it's always safest to do that. Okay, and now what you're going to do is connect channel 1 to the output of the transformer, making sure it doesn't make connections anywhere else, and channel 2 to the DC line, like that. And once again, I'd like you to run that simulation, set the graph to fit, and take a screenshot of that simulation and put it in a Word file as well, because what we're going to do is write a report on how this circuit works and what values we expect to come out of this circuit. Okay, so this, currently you should be seeing a graph that has got a lot of ripple. Okay, you should be seeing a graph that looks something like, if I can just find it, just give me 2 seconds. You should be seeing a graph that looks something like this on our DC. Okay, or even better, if I go down the full wave bridge rectifier, no, we can't see it on there because it's the same trace. You see here a good explanation of how the bridge rectifier works as well. Okay, and we'll be using that later on too. Okay, so that has got a lot of ripple. It's basically the full half waves of an AC cycle. We don't want that on DC. So what we need to do is add a smoothing capacitor. Okay, so again, I'm going to delete these 2 traces. I'm going to add a capacitor. So come to here, capacitor. I'm going to pick a 100 microfarad capacitor. I'm going to drop it in. Okay, that's all we're going to do. And now, again, we're going to, in fact, I could have kept that, so I'll put these so they're slightly out of the way. And then I can build the rest of the circuit. Because we're always really going to trace with the DC coming in now. Okay, and we're going to again look at what that output trace looks like. Okay, again, now run your simulation, and you should see that this, with the smoothing capacitor, we're getting something that looks like this. Okay, so our DC was rippling quite a lot. Our smoothing capacitor is smoothing that ripple down to a much smaller value. Now yours might still be bigger than this, it might be smaller than this. Yep, this is the whole point. And if we look down, you can see the effect of having different values of smoothing capacitor. So we've got 5 microfarad there, and we've got 50 microfarad there. So we should be finding the bigger the capacitor, the smoother this waveform gets. Okay, so that's our full wave bridge rectifier. Okay, with the smoothing capacitor, but we want our voltage to be at 15 volts, and you shall find yours is somewhere mid-20s, maybe, might even be slightly higher than that. Okay, so what we need to do is regulate our voltage. Now what we're going to do is move that resistor out a little bit, just give us some room. Okay, we're going to get a diode. but this time we're going to get a zener diode. Okay, now the zener diode is slightly different. We put the zener diode in reverse bias. So we're going to put the zener diode in like this. Okay, and I want you to double click the zener diode, come down to model, and I want you to find, in fact it doesn't look like there is, there isn't a 15, so let's put an 8.2 volt one in. Okay, this will give us the right idea of what's happening at least. Okay, I'm just going to move that so you can see. So this is an 8.2 volt zener diode. Now the one thing zener diodes need is protection. So we also need to put a resistor in. Okay, so we're going to grab our resistor, arrange that, and drop her in there. Okay. Now, what we now want to see, okay, is we've seen the ripple. So now what we want to see is the voltage across that zener diode compared to the voltage across the capacitor. And we must do it on this side of the resistor for channel 1. And what you should see now, run that simulation, and what you'll see is that this voltage is our Ripley voltage, which is about 25 volts, something like that. And then underneath that, at 8.2 volts, we should see a flat trace. Now, I did all my calculations for 15 volts, so you might find some of your components to get overheating, some of them might explode if you've got explosions on. Okay, that's okay, just turn the explosions off and you should see the readings. Okay, if you can get that voltage run, get those waveforms snipped, that'll be perfect, and we'll be able to then take what we've done forward into the lesson when I can get the simulation myself running. Okay, hope you can follow all that, and I hope that's helpful. All right, and from that I shall let you go. He says, trying to find the right